Welcome back to eCoreAcademy, students. My name is Anita Raj, and I am one of the teachers and co-founders here. Today, as you can see, I have a new Algebra 2 lesson prepared for all of you math students. It's going to be a continuation of our mini-series on quadratic applications. Just a quick recap, the first video I did, we really just ran through scenarios of quadratic applications because when I was in Algebra 2, applications in our quadratics unit were a big thing. They were a big deal. So we went over some scenarios of what you might see. In part 2, we did a problem together by hand. It was on number sense, so please watch that video. It's going to be linked in the description box below. Before you watch this one, it was one of the harder problems I picked. I purposely picked it because it's a more difficult problem, so we'll work through that together in that video. And this is going to be part 3. It's going to be the final video. It's another pretty difficult problem that I found difficult out of all the quadratic problems we were given. These two from part 2 and this one from part 3 are not straightforward. That's why we're going to be working through them. Let's work through our weaknesses. So we're going to be doing a practice problem together. This one is going to be about area. Last one was about number sense. This one's going to be more of a realistic application of this. So you're going to be given like a realistic scenario, and then we're going to be using Algebra 2 concepts and quadratics to solve it. Before I even get into the video and even solving this problem, I would really appreciate it if you paused and liked the video to show your support towards this channel, myself, and AJ, and everyone behind the scenes who are supporting us as well. Also, hit the subscribe button so you can join the student community. Hit the post notification bell so you're notified of our latest posts, and don't feel afraid to drop a comment down below. We'd love to know what our students think. Lastly, please use our socials in the description box to follow us on all of those platforms, including Facebook, Twitter, and Instagram. You can just really help us up our game and get the word out to more students who could benefit from the material we have on this platform. Okay, now let's get into the video. So here's the problem about area. Let me just give it to you now. Here's the problem. Like the last video, in this green box, you'll see the overarching concept. So this problem is going to be broken down into 5 parts. Just like the last problem, it's very similar in format, and even the approach we take to solve it, those two things are very similar. But again, it's a totally different quadratic application. So here's the actual concept that I want you to keep in mind as we go through this problem. This is going to be like the ultimate question we answer at the end after we've gathered all our information. A rancher is like a farmer, like a farmer with a lot of land. For those of you who are not familiar with the word rancher, so think farmer, has 200 feet of fencing. So if you look at your backyard or your front yard or even around your house, around the perimeter of your property, you might see a fence, whatever fence it is, wire fence, wood fence, any other kind of fence. So this rancher, this farmer, has 200 feet. So if you think about the perimeter, so 200 feet worth of fencing. And he or she needs to enclose 2 adjacent rectangular corrals. So corrals are like pens. So if you think about livestock like cows, goats, sheep, horses, whatever, we'll keep them in like a corral to kind of keep them in one area. So it's not closed like a barn. It's like an open area. And what they're telling us are these 2 corrals are adjacent to each other, meaning they're right next to each other. Like if this was one of them, this was the other one, they're right next to each other. And they're rectangular, so you obviously know what a rectangle is. And they are the same size. So these 2 corrals, adjacent, right next to each other, rectangular, and they are the exact same size. So that is what you need to know. As you solve this problem, answer the following questions. There's going to be 5. So first, we want to write a function to model the situation. There is a quadratic function that we can derive from this. I know it looks like very little information has been given, but on the next slide, I'll actually show you a diagram that is provided with this problem. And using that diagram and this overarching idea, we're going to be coming up with a quadratic function to model the situation, just like we did in the last video about number sense. It's going to be like pretty much the exact same approach. Then we're going to be answering the question, what does the x-axis represent on the graph? So we're going to be answering that question, and accompanying that, we're going to be answering the second question, what does the y-axis represent on the graph? Next, we are going to be giving the dimensions for each corral. So we're going to be giving the length and the width of each corral, not the whole area. So even though the corrals are right next to each other, we're not giving the dimensions of the entire area. We're going to be looking at one corral because remember, they're both similar figures, meaning they're both congruent to each other. So we're just going to be finding the length and width of one of them, and then it'll obviously represent the other one as well. And lastly, we're going to be finding the maximum area of each corral. So we're going to be answering all of these questions and just working through this problem together. So let's get into the first one. Write a function to model this situation on the next slide. Okay, so again, the problem is going to appear at the top of the screen for all of you, this overarching idea, and you'll just be able to refer to it just in case you forget or there's some kind of information. So before we even get into writing a function, I want to show you this diagram. So here's the diagram. This is what your actual fence looks like. So on the left-hand side, you can see a corral. It is rectangular. You can see that the length is not exactly equal to the width. We can't assume that, but just from the diagram, it looks that way. They both share a common side. So if you see that middle divider, we can assume that's a common side. So they share that common side, and they're adjacent to each other. So they're literally touching. And to make it a little bit easier, I've actually labeled this. So if you look at the vertical, I want to call them vertical lines. You can look at them as the width or even the length, whatever is easiest for you. So whatever is labeled X is congruent to each other because if you think about it, the width of this side, let me draw it here. The width of this side that I'm circling here, the length of this side is equal to the length of this side because remember, our two corrals are congruent to each other. They're both rectangular, so these two sides are equivalent. Remember, this is a common side between them. So if we thought of two rectangles, like I'm drawing them at the top of the screen. So this is one rectangle. This is another rectangle. This X right here, this one right here, is like these two sides of this side of this rectangle and this side of this rectangle were just merged together. So this is also equivalent to this X and then this X to the right. So those are all I labeled X because they're all congruent. Then the top part and the bottom part that are parallel to each other, those we'll just refer to them as the length for now. They encompass the length of both of the rectangles. So this Y right here, it compensates for this rectangle's length and this rectangle's length. And same with this Y. So these guys are congruent to each other. So when we finally give the answer, remember, they're asking for the dimensions of each corral. Just for the sake of labeling this diagram, I've labeled that whole length as Y. However, when we get to the final answer, we're going to have to divide that length by 2 to find what this individual length is. So this would pretty much just be Y divided by 2. And then this would be Y divided by 2. But don't worry about that yet. Just keep in mind this diagram. I won't be able to put it on every slide, but just keep it in mind. If you're taking notes, I'll give you a second if you just want to pause the video and copy this diagram down. Whatever you need to do, but just know that we're not going to be going back to this diagram. Okay, I hope that was enough time for you to copy this down or take a picture or whatever you needed to do. Let's go to the next slide. We're actually going to be solving the problem now. So here's a solution pre-written for the first question. And remember, the first question was write a function to model this. Well, it's mostly a statement. Write a function to model the situation. So you're writing a quadratic application based on what you know to model this situation. So here's the solution pre-written. I've already written it out for you. As you can see, it's very similar to the number sense quadratic applications part 2. It's very similar to the approach we took for that question. So this should be familiar to you if you've watched that video. And I don't need to spend a lot of time talking about this because hopefully you watched that video and understand all of this stuff. But if you'd rather copy it down and then listen to me explain on the next slide, go ahead. Feel free to do so. I'll give you a second to pause the video. Okay, I hope that was enough time. Now let's go to the next slide where we will be solving this together. So again, remember that diagram. I'm just going to give you a little sketch up here. It's not going to be perfect, but remember, it's like this long rectangle split into two rectangular sections. This top part we called y, this bottom part we call y because they're congruent to each other. This side we called x, the barrier between we called x because it is congruent, and then this side we also called x. So that's just a very rough diagram. So first we want to understand what we need and what we have. So what do we need? Well, we need the length of x because that gives us the dimension. We need to label it, like we need to acknowledge it. It's an important part of this problem. We need x because it gives us the side length. Y we also need because it gives us the other side length. So we can think of x as like a width and then y as a length if that's easier for you. So we need we need to know how long the width is. We need to know how long the length is. We also know that we have a total of 220 feet of fencing. Because if you think about this, wherever I've drawn that line that outlines that shape, that's where the fencing is going to go. So all of that fencing, including all your x's, all these vertical lines right here, and these two horizontal lines, imagine a fence being placed on top of them. So all of that, all the sides combined with that barrier in the middle has to equal 200 feet of fencing because remember perimeter, we have the perimeter of those two curls combined with that barrier in between. Lastly, because we're asked for the maximum area and the last question area is also going to play a factor. So if you want to think of the 220 feet as perimeter and then area as a totally different thing, go ahead. You can think of it that way if that's easier for you. Okay, so let's label our variables like we did in the last problem in number sense. So x is going to be equal to our first side length. You can think of it as your width. I'm just going to call it side length because different people might think of it in different ways. I don't want to confuse you. Y is equal to our second side length. Remember that horizontal side length, the longer one, second side length. If you don't know what I'm talking about, you can refer to the rough diagram I drew at the top of the screen. Second side length, 220, which I called our perimeter just to help you guys understand what it is our total fencing. So that's the total fencing we have available to place on that yellow line I've outlined. So imagine it as the fencing you're placing on top. That's how much fencing we have to do that. And then lastly, A is equal to area. Remember the last question asks us to find the maximum area after finding the dimensions of each corral. So that area is going to play a major part in this as well. Okay, so now we're going to be writing two equations and then combining them together to make one equation in terms of one of the either x or y. I'm not going to tell you yet. And we are going to have that as a quadratic. So first, let's say, like I told you, all of our sides added together have to equal 220 because 220 is the maximum fencing that this farmer or rancher has available. So let's write that out. So let me write it over here. So look over here. So we have this x side length right here. We have an x side length right down the middle and an x side length over here. Therefore, we have a total of 3 x's. So I'm going to write 3x. And then if you look at the y's, we have 2 y's. So plus 2y. All of these side lengths together have to equal 220 feet. By the way, everyone, on the last slide, I just realized, let me go back to the last slide. Okay, everyone, I just realized I made a small mistake. This should not be 220. This should be 200. So I'm going to rewrite this as 200. And over here, I need to rewrite this as 200. So, because if you look at the top, it's 200 total feet. So 200, 200. If you go back to the last slide, if you copied it down ahead of time, right here I've written 200 or 220. It should be 200. I'm very sorry about that. Okay, now let's continue with the problem. Okay, so we have 3x, which is the 3 vertical side lengths, plus the 2y, which are the 2 horizontal side lengths, equal a total of 200 feet of fencing. So we got that down. Now we got to pick one of the variables to isolate. And let's just pick y for this case. So we're going to subtract 3x from both sides to get 2y by itself. So subtract 3x from both sides. You get 2y equals 200 minus 3x. Now to get y by itself, let's divide by 2. Let's divide both sides by 2, and we get y equals 200 divided by 2 is 100, Negative 3 divided by 2 is negative 3 over 2, and that goes with x. So we know that the length of side y is equal to 100 minus 3 minus 1.5 minus 3 halves of the side of the value of x. So it's pretty much just the equation we just wrote. We just wrote the side length we wrote the side length y in terms of x. So we isolated y. Now what we want to do is we want to understand what the area is. So the area of one of these corrals, the area of the area of this whole thing, including both of the corrals, is equal to the width times the length, like any square, rectangle, whatever. So the area is equal to x, which is our width, times y, which is our length. So I'm going to write it down here. A is equal to x times y. So let's rewrite this using what we know. So we're gonna leave x as is, but look over here. We just wrote y in terms of x. So instead of writing x times y, we can do x times the quantity 100 minus 3 over 2x, because we know that that's what y is equal to, and we're trying to get rid of that y, so we're working with at least two variables here, which are a and x. So we just did that. So now let's distribute this. Let's do this right now. So x times 100 is 100x, sorry. And then x times negative 3 over 2x is just negative 3 over 2x squared, because now you have two x's multiplied together. So that would be your function. So this right here, I'm going to write underneath it function. So this would be your function. Now we have a quadratic in terms of the maximum area. Whoops, I'm trying to circle it for you. Okay, now we have a quadratic in terms of the total area, and we are going to be using this throughout the process. So this would be your answer to the first part. Area A is equal to 100x minus 3 over 2x squared. So that is your function. Now let's go to the next slide to answer the next question. Again, the topic's at the top of the screen. So now let's look at this second question. What does the x-axis represent on the graph? Okay, so because we have named our first unknown side length as x, remember the diagram here. I'll draw it up here for you very quickly. This is our long rectangle split into two rectangular corrals. Here is x, here is x, here is x, here is y, and here is y. Because we have named our first unknown side length as x, you can obviously see in the diagram we have three horizontal lines all congruent to one another, which represent the width of these rectangles, and we've named that as the unknown variable x, because we don't know what its value is. It has now become the x coordinate of our solution pair. So what does this mean? So if you remember our function, a equals 100x minus 3 over 2x squared that we wrote on the last slide, we have two variables. We have a, which is the area, and x, which is our first side length. So if you think about it, if you graph that, you will get a parabola. And the vertex is the answer to this, has two answers to this whole overarching problem. I also explained this in the number sense problem. So the x-coordinate of that vertex is the first side length. So if you graph that function and you get the vertex, the x-coordinate is going to represent the side length x in our diagram above. So the x-coordinate of that solution pair, which is the vertex, is going to represent the side length x in this diagram. So that's what you need to know. So therefore, the x-axis represents our first side length. The x-coordinate of the vertex represents that first side length. That's what you need to know. That's the answer to that first question. Now let's answer the second one. So what does the y-axis represent on the graph? So if you didn't watch my number sense video, you're probably thinking the y-axis represents the second side length. If I redraw the diagram up here, very, very quickly, here's your rectangle, here's your x, 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 y, y. Okay, so I redrew that. You're probably thinking that y, that long horizontal side length, is represented by the y-axis, and that is where you are wrong. Although the second side length is what we're calling y, even though we're calling it the variable y, when we actually graph, The area is the value of the function, so the value of the area is represented. So let me write out that function for you that we found from the last problem. A equals 100x minus 3 over 2 x squared. So we already said that x in this case represents our side length x. That was pretty straightforward. However, if you see right here, we don't have y written. We have a written. So we're not saying y is equal to 100x minus 3 over 2x squared. We're saying a is equal to 100x minus 3 over 2x squared. If we had y instead of a, then we would be saying that the second side length is equal to 100 times the first side length minus 3 over 2 times the first side length squared. But that's not what we're saying. Remember, we rewrote the second side length in terms of the first one. We rewrote y in terms of x, so we would get it down to two variables in this function. What this is saying is the area is equal to 100 times the first side length minus 3 over 2 times the first side length squared. So although we're calling the second side length y, in this case, the y-axis actually represents the maximum area, because here, in other terms, we can write this, if you're writing this as a proper function that you are graphing on the coordinate plane, a shouldn't be a should actually be y, because you always write your quadratics in the form y equals ax squared plus bx plus c, or you can write it in vertex form. You always have y in x, but because of this problem, we rewrote that as a to represent area. So you need to know that the area is the value of the function. So if I graph this as a if I graph this quadratic equation and I got a parabola and I found the vertex, which is your solution pair, your x-coordinate is your first side length. But your y-coordinate is going to be your area, because if you think about this equation gives you the value of the area. A equals 100x minus 3 over 2x squared. That gives you the value of the area, not the value of the second side length. So I'm inputting the value of the first side length, which is x, which is our x-coordinate of the vertex, and the answer I'm going to get out is the y-coordinate of the vertex. The answer I'm getting out is the value of the maximum area. So the value of the area is represented, not the second side length, because here the area is the value of the function. Remember, your y-coordinates are the value of the function at a given point. Therefore, the y-axis represents our area. So that's the whole explanation as to why that is. Okay, so now let's get into our last two problems. We're going to combine them together just so it's easier for me to explain it to all of you, for all of you to understand. So here are the second two questions. Last two questions. What are the dimensions of each corral? So if you think about that diagram, we're thinking of each corral individually, not all together, not that whole space, each one individually. And what is the maximum area of each corral? So each individual corral. So we'll find the dimensions, we'll find the width and the length, and then we'll multiply them together to find the maximum area of each corral. So here's the solution already written for you if you just want to use this. If you just want to pause and copy it down. I promise this one has no mistakes, so don't worry about it. I like to write this ahead of time for all of you, so if you want to listen to me speak on the next slide and not worry about copying everything down, this is meant for you. So I'll give you a second to pause the video if you want to copy this down. Okay, hopefully that was enough time for you to pause the video. Let's continue to the next slide, where I'll be going through both of these problems simultaneously, and then we'll be solving them. So here's the overarching idea. Here's the solution together, and those are the two questions, just in case you forgot. So first, I just want to draw this diagram up here. I'm sorry I couldn't put it on every slide. It's just I don't have space on the screen to do that, so I'll just draw it for you with my amazing drawing skills. Yep, those are your size x, and this is y and y. Pretty straightforward. Okay, let's answer the first question. What are the dimensions of each corral? So first, let's rewrite our function. Give me a second. Let's rewrite that function that we had found. A equals 100x minus 3 over 2x squared as... I want to put the x squared term first. I want to put the 100x term behind it, because I want to go in descending order of exponents, and I'll show you why. So we're going to move that negative 3 over 2x squared to the front, and then push that plus 100x to the back. And I'll show you why this is kind of fascinating. So if you look at this, it should remind you of standard form. I know it's not perfect standard form, but it should remind you of standard form. And for those of you who forgot what standard form of a quadratic is, here you go. Y equals ax squared plus bx plus c. So I know we don't have all these components, like we don't have c. We're just going to assume c is 0, but we do have a and b. Whoops, I forgot to write this squared right here. So squared. We do have a and b. So what are a and b? Well, let's look in front of the x squared term. We have a is equal to negative 3 over 2. We have b, which is in front of the x term, which is equal to 100. So how does this help us? Remember, the vertex of this parabola is your solution pair. The x-coordinate is going to be your first side length, and meanwhile, the y-coordinate of the vertex is going to be your maximum area. So first, before we even start worrying about how am I going to find this, let's find what we know. Remember how the x-coordinate of a parabola is x equals negative b over 2a. Well, we can find what that first side length is that x is in this diagram above. So this is what I'm referring to. We can find out what this is using a and b because we know what a and b are. So let's do that over here off to the side. Remember, x is equal to negative b over 2a, which is, so negative b is equal to negative 100 over 2 times a, which is negative 3 over 2. And if you do all the math, you will get 2 times negative 3 over 2 is negative 6 over 2, which is negative 3. So you get negative 100 over negative 3, and that's just equal to 100 over 3. So if you just simplify all that, you'll get to 33 1/3, and we can just write feet. So we found out what the first dimension is. We found out what x is equal to. So we have that. So how are we going to find what y is equal to? Because remember, this is the x, what we just did here, x equals negative b over 2a. That is the x-coordinate of the vertex. Remember how we said the x-coordinate of the vertex is the first side length. However, the y-coordinate of the vertex is the maximum area. It's not going to be your second side length. It's not going to be y. So what we can do is, do you remember from the last slide, when we were solving, we said that 3x's plus the 2y's is equal to, so what we're trying to find is we're going to be using that 3x plus 2y equals 200. Remember how we tried to get y by itself and we got y equals 100 minus 3 over 2x. So what we're going to be doing here is we'll just rewrite that y equals 100 minus 3 over 2x. Well, now that we know what x is, we can just plug that in and find what y is. So y is equal to 100 minus 3 over 2 times 33 1/3. If you simplify this, you'll end up getting 50, so you get y equals 50. However, remember, for the dimensions of the corral, y encompasses this whole horizontal side here. We only want this half, so technically we only want y over 2. So what we're going to do is, since this is equal to y, and we want to get y over 2 just for that individual corral, we're not trying to find this whole length, we're just trying to find that individual length. We're going to divide this by 2. So this divided by 2 equals 25. So that is the dimension, that is the length of the corral. So the corral is 33 1/3 feet by 25 feet. So those are the dimensions. Lastly, we need to find the maximum area of each corral. And you might be thinking, oh, we can just take x, which was 33 1/3, and we can plug it into a equals negative 1/3 over 2x squared plus 100x. You might have thought about that because technically a is the area is equal to that, equal to this equation right here. We could do, let me just go back to pen. But many of you might have realized that the easiest way to do this, to find the area of that single corral, would be to multiply 33 1/3, which is our width, by 25 feet. That's the easiest way to do it because remember, area is equal to length times width. We know both of these values, so we don't need to plug it into this long, complicated quadratic. So we can just take a shortcut and just do area is equal to 33 1/3 times 25. And we'll find that if you do all that math, you'll find that the maximum area of one of those corrals is equal to 833 and 1/3 feet. So that's one of the corrals. That's not both of them. That's just one, and that's what the question is asking each corral. So that is how you would find the area. Also, before I end this video, I really want to apologize. If you see at the top of the screen, I've written sorry, wrong problem, because at the top of the screen, I've actually written find two positive real numbers whose sum is 90 and whose product is a maximum. That's from the last video, and it got copied onto this video. So remember, this video is about the rancher, not the number sense. And I also did it on the last slide as well. If you can see at the top of the screen, find two positive real numbers. Super sorry about that, but because I walked you through it, it should be fine. You should know all the information. So I just wanted to give you a heads up so you're not confused. Super sorry about that. Okay, so that's all I have for the video today. I hope you enjoyed, and I hope you were able to follow along and understood everything I was talking about. I think it's super interesting to go through these quadratic applications, but if you don't understand what you're doing, it can be mind-boggling. It can be so stressful. So hopefully these videos answered your questions. A lot of these quadratic applications involve critical thinking, so not only do you have to be a logical thinker, you have to also think a bit out of the box. You have to be like, okay, what does this variable represent? What does this variable represent? How can I put these two equations together to find to make an equation of one variable in terms of another, instead of having like 4 or 5 different variables that confuse me and I won't get anywhere in solving for those variables. So you got to apply those kinds of skills, and hopefully I showed you how to do that in this video and the last video. All right, so I really appreciate it if you liked the video and hit the post notification bell, subscribe to the channel, drop a comment down below, and share using our socials to do all of that. That's your to-do list. Please finish that. All the socials are in the description box below for you to check out. And of course, if you have any personal or business correspondences you'd rather do via email, please email us at eCoreAcademy@gmail.com. Lastly, I just want to make you all aware that we have a website coming out very, very soon. And here's the link on the screen. It's also in the description box. It's already out, but we're still in the process of setting it up. We'll do a whole video on a run through of the website. We'll be posting it all over our social media so you don't miss out. But that'll have a bunch of sweet functionalities like that you can't access on the YouTube channel, of course, like notes and quizzes and all these courses arranged in the easiest way for you to tackle all of these topics and make sure that you've covered everything that you possibly need to. So that's all I have for you today. I'll bring you more updates. Please look out for my next Algebra 2 video. See you soon and have a great day.